Imagine, you're an 18th century scientist dissecting a dead frog in the middle of a thunderstorm. When your scalpel touches its nerves, the detached leg suddenly kicks violently as if it's come back to life. This isn't a horror movie scene, but rather the most crucial moment in human history. This is the moment when humans realized that the breath of life was actually just electricity. This disgusting-looking experiment not only resurrected the frog's leg, but also gave rise to a technological revolution that's now in your pocket, the smartphone battery. It all started with a laboratory accident, accidentally caused by Luigi Galvani. Galvani wasn't a magician, he was a meticulous anatomist. However, the sight of a dead frog's legs twitching when struck by a spark of static electricity completely shook his logic. Galvani believed he had discovered animal electricity, a vital force hidden within the tissues of living things. For Galvani, the frog's body was a natural electric current, a store of electricity. He even hung the frog's legs from his balcony during a thunderstorm, just to watch them dance every time lightning flashed across the sky. His world was in an uproar. People began to wonder if we could bring the dead back to life if we had enough electricity. This was the real inspiration behind the novel Frankenstein. However, in another corner of Italy, a genius named Alessandro Volta sensed something was amiss. Volta didn't believe in the mysticism of animal electricity. He suspected that the frog was merely a victim, a wet conductor sandwiched between two different metals. To Volta, the frog's leg wasn't a source of electricity, but merely the world's most primitive electrical detector. This dispute became one of the most heated scientific debates in history. Volta wanted to prove that electricity could be generated without the need for living creatures. He began experimenting with piles of metals, copper and zinc, separated by cardboard soaked in salt water. He stacked them high, creating what we now know as the voltaic pile, or the world's first battery. Volta was so determined to prove his theory that he used his own body as a measuring tool. Since voltmeters were not yet available, he held the ends of his battery's wires to his tongue, his hands, and even his eyes to feel the electric shock. This insane dedication paid off. He succeeded in creating a steady, continuous flow of electricity for the first time in human history. The world no longer needed lightning or frog legs for energy. It now had batteries. What began as a twitching frog's leg has now become the lifeblood of modern civilization. Volta's discovery overthrew Galvani's theory, but history has shown that both were correct. Our bodies do use electrical signals to move muscles and send messages to the brain, but electricity itself can be created artificially through chemical reactions in metals. The leap from Volta's first battery to today's digital age is massive. Without an understanding of how electrons move from one pole to the other, we would never have microcontrollers, touchscreens, or electric vehicles. We have transformed from creatures afraid of lightning to creatures capable of storing lightning in a tiny box called a lithium-ion battery. However, this immense power has a very physical weakness: connectivity. Just as a frog's nerves transmit motor commands, our civilization is now connected by a giant nerve, consisting of thousands of kilometers of fiber optic cables and undersea internet cables. Electricity and data are now an inseparable package. Ironically, the technology born from this grand experiment is often crippled not by scientific failures, but by trivial human actions. Imagine a billion-dollar online trading ecosystem or a global banking system could suddenly shut down completely simply because of a mischievous hand carelessly cutting an internet cable. We have built a towering technological tower, but its foundation is still physical cables that need protection. The lessons of Galvani and Volta are not just about how to create electricity, but how to value the flow of energy and information. Science has come a long way, from a dissecting table filled with dead frogs to satellites orbiting the Earth, simply to make it easier for us to communicate and work. We owe a debt of gratitude to the frog's leg, which kicked in Galvani's laboratory. Without that little kick, human curiosity might never have been piqued to invent the battery. And without batteries, the world would remain dark when the sun sets. Our future now depends on these cables and batteries. Maintaining them is no longer just a technician's job, but our responsibility as part of a digital society that cannot survive without the flow of electrons discovered hundreds of years ago.